Moving on, we need to be able to reference our unit circle knowledge and our understanding of the triangles to solve trig equations. This is something that you have to know. So, how am I going to solve a trig equation? I'm going to first start by isolating the trig function. Solving by subtracting, by dividing, whatever you want to do to isolate the trig function. Now, I need to use my unit circle knowledge to figure out when is sine of an angle going to give me a value of 1/2. This is what I do. I first think, okay, sine, vertical. Vertical side length of 1/2. I'm thinking about creating a triangle with an angle where the vertical side length is 1/2. I know a triangle whose vertical side length is 1/2. It is a 30, 60, 90 triangle whose horizontal side length is √3/2. This is a pi/6 triangle, or a short 30, 60, 90 triangle. I need to find the pi/6 locations that give me sine values that equal a positive 1/2. You might think, oh, that's my answer, pi/6. That's not all my answers. We are looking for all solutions between 0 and 2 pi. 5 pi/6 is my other one. Now, here's an easy way to remember, like the other locations. I like to do this. Remember this acronym, ASTC, all students take calculus. This is telling me which trig function is positive in which quadrant. So all trig functions are positive in the first quadrant. So sine's positive, that's why pi/6 works. Sine is positive in the second quadrant. So since sine of theta equals positive 1/2, that's why I know I need that pi/6 in the second quadrant. Now, what is it? Again, you have to be able to find the angle. I know this is 6 pi/6. Need to go clockwise. That is in a negative direction. So I'm subtracting a pi/6. That's why I know it's 5 pi/6. We didn't have to subtract 3 first, then divide by 2. You could have divided by 2 to start with. But what people don't understand is that if you're dividing by 2, you're dividing everything by 2. This is why we don't teach that. Yes. So this would be sine theta plus 3/2 equals 2. Sine theta equals 1/2. This, you don't have to distribute first. You guys are old enough to kind of figure out the different ways to solve equations. If I divided by 2, since it's 2 times this entire quantity, I could have just divided everything by 2, and the 2 would have gone away, just left me with cos theta minus 1 equals negative 1/2. And then add 1, I get cos theta equals positive 1/2. And now I need to solve. Cosine equaling 1/2. This is what I think about. My horizontal side length is 1/2. I'm thinking about an angle, and the horizontal length to that angle is 1/2. Okay, well, I know a triangle where the horizontal length is 1/2. It is my taller 30, 60, 90 triangle, where the vertical side length would be √3/2. This is my tall triangle, which is created from my 60-degree angles, which is my pi/3s. So I need pi/3 because I know that cosine is positive 1/2 here. Where's my other pi/3? In which quadrant? The fourth. Why? Because of either this C, or it's like, oh, I need to know when it's going to the right. So the pi/3 over here. How do I know what that pi/3 is? I start with 6 pi/3. I subtract a pi/3, and I get to 5 pi/3. If you are very uncomfortable doing this, you will need to practice. All right, let's do the next two. Now, a reminder, we look for all solutions from 0 and 2 pi, including 0 and 2 pi. So the first one, we get x equals pi. For the second one, subtract 4 divided by 3. Well, after I subtract 4, I get the sign of x is equal to 0. Sign, vertical, vertical, 0, 0, pi, 2 pi. Okay. Now, all of our answers have been between 0 and 2 pi. We haven't had to look or worry about anything beyond that. But know that angles don't stop at 360 degrees. You guys ever watch the X Games? Ever seen cool kids on wakeboards? Okay. So if you're doing a 0, you're just going straight, right? You pop a 360, you're pretty cool. You end up in the same places where you were when you started, right? So 360 degrees, you started at 0 and you ended at 0, right? But it's different. Well, if you're really cool, you could pop a 720. Now, I'm really cool now. I just did 2 spins, but I ended up back where I was. But did I do something different than a 360? Yes. So we can continue to go around the circle and end up at the same locations, but they are different angles. Does that make sense? If you're able to pull a 4 pi, you're a lot cooler than if you could pull a 2 pi. All right? So we need to keep that in mind. If I took away this restriction and I said, find the solutions, you would have to consider all of the solutions where the angle that gets referenced ends up here at pi over 6 and here at 5 pi over 6. Which means if I go around the circle again and end up in the same location, that is a different angle, but it ends up in the same location as where pi over 6 is. Just how 0 and 2 pi end up in the same spot. Now, if I add 2 pi to pi over 6, what do I get? Well, let's think about that. 2 pi is the same as, okay, 12 pi over 6 plus pi over 6 gives me 13 pi over 6. That is technically a solution. If I start at 5 pi over 6 and add 12 pi over 6s, that gives me 17 pi over 6. And I can continue to go around the circle over and over again forever. There's certain notation that sometimes we use, like multiple notations, where it's like, take this, add a multiple of 2 pi. Take this, add a multiple of 2 pi. As long as you're adding an integer multiple of 2 pi, and you'll get all the solutions. We can also go negative. So this ends up being negative 7 pi over 6, and this is negative 11 pi over 6, okay? We didn't have to worry about that, though, because I told you 0 to 2 pi. Well, we will have to worry about that for these, which is why they're tougher. Because it's not just a sign of theta, it's a sign of a multiple or a divisor of our variable. And watch what we have to consider. Now, the first thing we have to know is that you can't get rid of the 2. So don't try to get rid of the 2. It's in the sign. You'd have to get rid of the sign first before you get rid of it. Instead, pretend like it's not there. Pretend it's just like the sign of something equals root 3 over 2. You can use a different variable like y if you want to. Let's just go with sign of something. Now, again, you got to use all of the stuff we talked about to be able to figure this out. Sine, vertical. What is my vertical? Root 3 over 2. Okay, my vertical, root 3 over 2. Will happen if my horizontal is 1/2 and my hypotenuse is 1. So again, this is my tall 30, 60, 90 triangle that occurs at the pi over 3s. The pi over 3s, when sine is positive, are here in the first quadrant and here in the second quadrant. Pi over 3, 2 pi over 3. But these are not my answers. Because I'm not looking for just theta, I have 2 theta. This stuff inside 2 theta has to equal those angle measurements. If you wanted to do like a y, you'd say, okay, y has to equal that, but y is equal to 2 theta. Watch why that's important. Because to solve for theta, I need to divide by 2. I'm going to divide everything by 2. It's the same as multiplying by 1/2. So this turns into pi over 6. That is a solution for theta. This turns into pi over 3. Great. Those are my actual solutions. You take pi over 6, you plug it in here. It turns into pi over 3. The sine of pi over 3 is root 3 over 2, so we're good. But these are very much so inside of 0 to 2 pi. Remember, we want all of our solutions between 0 and 2 pi. What that means is that I might have to expand my first set of solutions that I found, that we just talked about, where I'm going to take these solutions and add 2 pi to them so that I get back to where we want it to be located, but it's a different angle. If I add 2 pi to pi over 3, well, let's think 2 pi is 6 pi over 3 plus a pi over 3, 7 pi over 3. Well, watch this. Take 7 pi over 3 divided by 2, 7 pi over 6. Is that between 0 and 2 pi? Yes. So that actually is a solution that we have to include. We want to get back to 2 pi over 3, but we want to go around the circle again. I'm going to add another 2 pi. Add a 6 pi over 3, I get to 8 pi over 3. Divided by 2, that's 4 pi over 3. This also between 0 and 2 pi. Maybe I need to do it again. Maybe I need to add 2 pi over 3 to 7 pi over 3. Let's see. 6 plus 7, 6 pi over 3 plus 7 pi over 3, 13 pi over 3. Let's see. 13 pi over 3 divided by 2 turns into 13 pi over 6. No. That is bigger than 2 pi. How do I know that's bigger than 2 pi? 13 divided by 6, bigger than 12 over 6. So I know 13 pi over 6 is bigger than 2 pi. So I actually understand the angles that I looked for originally so that my manipulated solutions are all the solutions between 0 and 2 pi. Let's think about this one. Cosine of x over 2 equals root 3 over 2. Ready, set, let's go. We could start by thinking about like the x over 2 not existing and just like thinking about what is cosine going to give us negative root 3 over 2. Okay, so go ahead, tell me and find out 2 solutions for when cosine gives me negative root 3 over 2. Cosine is negative root 3 over 2 at the pi over 6 here and here. Why? Because root 3 over 2 would be the longer side of my 30, 60, 90 triangle, which is created through my shorter 30, 60, 90 triangles at the pi over 6 is this being 5 pi over 6 and this being 7 pi over 6. You need to be able to get there. So there's that one, and there's that one. But that's not my answer because it's the cosine of x over 2 that needs to give me root 3 over 2, negative root 3 over 2. What do I do to solve for x? Multiply by 2. Multiply everything by 2. 5 pi over 3, or 10 pi over 6. 7 pi over 3, or 14 pi over 6. Okay, am I done? Am I good?
No.
No? You can't have 7 pi over 3. This is bigger than 2 pi. Okay, so in the previous one, I had to expand. In this one, I actually needed to contract the angles that I looked at. But I can't figure that out until I kind of do the manipulations and I solve. Let's look at the next two. These sometimes confuse students. I'll show you a way you can do it so that it makes sense. Now, which triangle is the vertical side length and the horizontal side length the same? 45, 45, 90, the pi over 4 triangle, right? A lot of people will look at this and say, okay, sine is positive and cosine is positive at pi over 4. That's my answer, but they would be incorrect. And this is how I'm going to show you it. Let's not think about sine equaling cosine. Let's get rid of this cosine by dividing cosine by both sides. That gives me tangent equals 1. Tangent is not just going to be equal to 1 in the first quadrant. Tangent will be equal to 1 here in the first quadrant at the pi over 4, but tangent is also positive here in the third quadrant. So tangent will equal positive 1 at this pi over 4 as well. 0, this would be pi, that's 4 pi over 4. Add a pi over 4, I get to 5 pi over 4. Those are my two solutions. Some people see this, and they might think, okay, cosine has to be negative, sine's positive, but they're the same, and they go to this pi over 4 only. But they are wrong. The way I can show you that they are wrong is, again, if you divide by cosine, you have tangent equals negative 1. Tangent is not just negative here, tangent is also negative here, which is why I have two solutions at 3 pi over 4 and 7 pi over 4. Okay. Last one, then you guys are going to try it out. We will have lots of equations like this in this class. The key to this type of equation that I'm referring to is this. We will have lots of equations set equal to 0 in this class. And when you have an equation set equal to 0, having a product on one side will help us tremendously. Now, I do not have a product right now. I have a sum. I have this one plus this one. But we will be factoring very often in this class to turn a sum into a product. And I'm going to factor out a cosine from both of these terms. Now, remembering factoring is just like dividing, unless we're factoring like a trinomial, then it looks a little different. If I divide out cosine and theta from both of these terms, I'll have 2 cos theta left over from this term, because these cosines will cancel. And these will cancel, but it will leave us a 1. Now, the zero product property states that if one piece of a product is 0, the entire thing is 0. So that actually enables us to create two separate equations. This piece set equal to 0, and this piece set equal to 0. Go ahead and solve both of those. Cosine equaling -1/2. Thinking of a triangle where the horizontal side is the half. Okay, that's when the vertical side is √3/2. That's my taller. That's at my pi/3s. But cosine is negative in the second and the third quadrants. So I need the pi/3 here, and I need the pi/3 there. You can start with 3 pi/3, subtracting a pi/3 puts you there, adding a pi/3 puts you there. So 2 pi/3, 4 pi/3. Those 4 angles will be solutions for this equation, which is pretty cool. You can list them off in order for practice. Let's solve these last 4. Look at that. Lot of solutions by adding 2 pi. Okay, I had to continue to add 2 pi because whenever I took this and divided it by 3, my angle got significantly smaller. So I actually had to add 2 pi twice, which is pretty cool. And this guy, when it's sine 0, so that's when I'm not going up or down at all. 0, pi, 2 pi. When do I go down 1 unit? 3 pi over 2. Okay, you isolate the trig function. You then think of the triangle. You think of the location of the triangle. For cosine x equals negative root 3 over 2, cosine being the horizontal, I need a triangle whose horizontal side length is root 3 over 2. That's the shorter 30, 60, 90 triangle. Those occur at the pi over 6's, the 30 degrees. I need the pi over 6. When cosine is negative, though, so I need this pi over 6 and this pi over 6. 6 pi over 6 minus a pi over 6 plus a pi over 6 gets you that. Next one. Oops. The next one, we end up just thinking about cosine equaling a half. Half for the cosine, the adjacent side, the horizontal side, so it's the taller. When is cosine giving you positive here and here? This taller is at a pi over 3. So I need the pi over 3 in the first and the fourth. That's pi over 3 and 5 pi over 3. Why is it 5 pi over 3? I go to 6 pi over 3, subtract the pi over 3. But then, to solve for x, I multiply everything by 4. When I multiply this by 4, it's 4 pi over 3. That's good. I multiply this by 4, it's 20 pi over 3. That is not between 0 and 2 pi, so that's not good. Here, when it's, I was thinking of cosine again. Sine is negative in the third and the fourth quadrants. It's equal to root 2 over 2 at the 45 degree angle, so that's the pi over 4s. So that's why we have starting with 5 pi over 4 here, and then 7 pi over 4 here. But when I solve for x, I had to multiply things by 3. Sorry, divide things by 3, giving me 5 pi over 4 turned into 5 pi over 12. Definitely between 0 and 2 pi. I need to get to 24 pi over 12. So that's why I continued to add 2 pi to get to the same angle location, but different angles, and continue to go until I get to something very close to 2 pi, ensuring that my next one that I found would be beyond 2 pi. Finally, this one, again, we factor. We have an equation set equal to 0. We have 2 equations after we factor that we solve. One is sine 0 at the horizontals, one is sine negative 1 at the vertical on the bottom. If you cannot do this quickly by Monday, you will struggle for the rest of the year, I guarantee you. Because we move on, and trigonometry pops up occasionally. And if you don't know what you're doing, every single trig problem is going to really weigh you down and hurt you for the rest of the year. So your plan is, if you struggled, you're going to come in and see me. And we're going to make sure you're struggling less by the time we take the quiz on Monday. This is not, oh, I'll be fine. It's still the first couple days of school. This is, you must know this right now, or you are going to not like this class. All right.